Hello everyone, and welcome to this video lecture. You'll note I'm in a new location. I've temporarily moved to my sister's house to actually help her with her statistics class. She's not taking at UNC, she's taking at UNC Greensboro, actually. So today, as of now, we should have gone through a bunch of the different measures for center, shape, and spread when looking at distributions. And today I'm going to walk us through some examples of how to calculate these metrics, and then I'm going to move on to an Excel tutorial on how to do a bunch of the stuff we've talked about on Excel. So I have an example, a motivating example. So remember, whenever we're talking about distributions, we're talking about the values that a single variable takes and how often it takes those values. So I'm going to have a tiny example. It's going to be tornadoes. Is there an E in there? I don't actually know. I hope not. So, I don't know if you knew this, but Oklahoma actually has more tornadoes every year than any other state. And suppose the following are the number of tornadoes recorded in and around Tulsa, Oklahoma over the years 2011 to 2019. So maybe in 2011 there were 7, 2012 1, and then so on and so forth. And we want to say what we can about the center, shape, and spread of this distribution of numbers. So let's start with center. In terms of center, we had 3 metrics, the first of which was the mean. And that was the sum of the xi values divided by the number of values that we had. So that summation notation is the same thing as saying like x1 plus x2 all the way to, in this case, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9 to x9 divided by 9. So since n equals 9 here, this would be 7 plus 1 plus 3 plus 4 plus 4 plus 6 plus 3 plus 5 plus 3 over 9, which is 36 over 9, which is 4. So the mean here is 4, and that is one of the ways we can think about the center of this distribution. The next metric, the median, what we do is we order the numbers. Which I've done for us here. And we just look at the center value. So there are 9, 1, 3, 3, 3 are the bottom 4, 4, 5, 6, 7 are the top 4, which puts 4 as the median. So both the median and the mean are the same in this example. And the last is the mode, which is just which value occurs the most often. We can say see that there are 3 3s, and there are less amount of every other number. I hope I said that in a reasonable way. So our mode is 3. Next I have a note. So these are our measures of center. What if in the year 2020 there was a large amount of tornadoes? So this is all of the number of tornadoes for the years 2011 to 2019. What if 2020 there were a ton? We observed 25. Then if you were to do these calculations again, you would notice that the mean would become 6.1. It would become greater than it was previously, while the median would actually stay the same at 4. And what this means is the mean is a measure that is sensitive to outliers. Now, we spoke about outliers before, values that were just so much greater or so much less than the other values that we've observed. Mean is something that will change whenever, well, it is likely to change whenever there's the presence of outliers, whereas the median, it may change, but it won't be as significantly affected. All right. So those were our measures of center. Let's move on to examples of spread. So I gave us the formula, the sample variance, that's what we call this, is equal to xi minus x bar, where x bar is the mean of the sample, squared over n minus 1. So recall we already calculated the mean of the sample, so x bar is equal to 4. I'm using not the one with the outlier, but the original sample that we talked about. Goodness. Let me turn on Do Not Disturb. So x bar is equal to 4. So what we do is, I think the best way to get through this calculation is to write a table like so. So our x observations are and next, we want to know the deviation of each of these observations from the mean. So what is the difference between each observation and the mean? And that is, well, 1 minus 4 is -3. 3 minus 4 is -1. So all of these are -1. 4 minus 4 is going to be zeros. 5 minus 4 is 1. 6 minus 4 is 2. And then 7 minus 4 is 3. So next we want to know what all of these deviations squared are, which is just going to be the square of each of the values in this column. So what is that? 9, 1, 1, 1, 0, 0, 1, 4, and 9. Now we want the sum of all of these, which is, you just add up all the things in this third column, which if you do, which I did already, is 26. And then the final thing we want to do is we want to say, okay, so the sample standard deviation, or sample variance, excuse me, is equal to the sum of all those deviations, the sum of all those deviation squares, which we just calculated, divided by n minus 1, which in this case is going to be 26 divided by 9 minus 1, which is equal to 3.25. Cool. So this is the sample variance. If you wanted the standard deviation, this would be equal to the square root of the variance, which in our case is the square root of 3.25, which is approximately 1.803. Nice. So the other way to measure spread that we talked about was the IQR. So in this case, much like when we calculated the median, what we want to do is order our observations. And recall our median was here. And what we want to do is we want, oh, excuse me, median is here. What we want to do is so we have the median right here. We want to find the value for the first quartile such that 25% of the values are on the left of it and 75% of values are on the right of it. And that's kind of be like the median of the values below the median is likely a good way to think about it. So in that case, that is right in between these two threes. And what's a number between 3 and 3? There's only one possible number. It's going to be 3. And here, it looks like it's going to be right between 5 and 6. And in this case, I would say just choose 5.5. There are some more algorithmic ways of approaching this, and actually I'm going to show you in Excel. Excel calculates this a little differently. The difference doesn't make too much of I wouldn't say the difference is too significant, but just know that usually when we calculate it, we just take them together and find the midway point, which in this case is 5.5, midway between 5 and 6. But if you use a software to do it, it might come up with a slightly different number, but that number will be between 5 and 6. All right, so for the IQR, we've got our first quartile and we got our third quartile. So IQR is equal to the third quartile minus the first quartile, which is equal to 5.5 minus 3, or 2.5. All right, that is the example of spread. To talk about shape, we actually need to look at the distribution of the numbers, which we do using a histogram or a box plot, which I hope by now I plan on getting to box plot on the lecture right before this, but if we didn't, then just hold on tight. You're going to know how to do it on Excel before you actually know what it is. So these are our examples of the metrics we talked about for center and spread. What I'm going to do next is go onto Excel. So I want to stop broadcasting. And I'm going to share my screen on my computer. Nice. So here are a number of tornadoes. I included the outlier here, if you'll note. And I want to show you all how to do a number of metrics using Excel. So first, the mean. What you want to do is you want to press the equal sign here and do average, AGE, and just select the numbers you wish to average. Press enter, and it got 6.1. So I believe that's actually what we said, wasn't it? Yeah. The mean with the outlier was 6.1. So Excel is working, or I guess we're right. The other way is just mode and select the numbers. It's really not that hard. And yes, the number that shows up the most is the number 3. Both of these things check out. For the other ones, we're going to be using this function called quartile. So equals quartile. And there are a number of ones you can do. I like using the quartile inclusive. Whoops. Goodness. Quartile inclusive. Again, select your data. And in this case, to get the first quartile, you do comma 1. Press enter, and that checks out. We thought our first quartile was 3, and indeed it is. The median also uses the quartile function. So select your data, but you're going to do 2. And that's because the median is actually the same thing as the second quartile. They're just 2 words for the same thing. And indeed, 4 is our median, which is something that we acknowledged on the notes I just wrote out. Let's do the third quartile. And this is when, because of the algorithm, it's going to be slightly different than what we got. We got 5.5. Excel is saying 5.75. The reason for that is a little nuanced, and I would just say use whichever one you prefer. It doesn't make a big difference for the type of computations that we're going to be doing. The IQR is just the third quartile minus the third quartile, 2.75. And once we have the IQR, we can actually calculate the lower outlier cutoff and the upper outlier cutoff. And the way we do that is the lower outlier cutoff is the first quartile minus 1.5 times the IQR. So that is our lower outlier cutoff, which we would probably in this context just say the lower outlier cutoff is 0 because you can't really have negative tornadoes. I don't know, maybe you can, but I would have to leave you to think about that. I can't think of a way that would happen. And the upper outlier cutoff would be the third quartile plus 1.5 times the IQR, which is 9.875. So yes, that year 2020, if we had seen 25 tornadoes, that would very much be an outlier, and we should probably investigate that observation a little bit. Something's going on. All right, so I think, oh, one more, excuse me. The sample standard deviation. For this one, the function is standard dev.s. So make sure you use standard dev.s, not just standard dev, because the s is specifically the one where we divide by n-1, and the standard dev is a different calculation. That's what we got. Oh, that's not what we got because we did it with the outlier here. So with the outlier, it's something a little bit differently. Let's do it without the outlier, see if we get what we expected to get. Yes, that is the standard deviation that we got. So standard deviation on the data without the outlier gets exactly what we got. If we add the outlier, of course, it's going to increase our standard deviation. Cool. So the next thing I want to show you is how to make a box plot. So what you want to do is you want to highlight your data. You want to go to Insert. For me, it's right here, box and whisker. And boom, there's your box and whisker plot. This one's very simple. What I want to show us next is how to do a histogram. And to do a histogram, you need to have this special tool. It's an add-on in Excel to be able to do it. So for me, I would go to Tools. I hope you can see this. But go to Tools on the top bar, go to Excel Add-ins, and then select Analysis Tool Pack, which should be one of the options in your add-ins. And once you do that, just press OK, and then restart Excel. And once you have done that, you should be able to highlight your data, go to the Data tab, and click on this value right here, Data Analysis. Hope you see it. So if you have trouble getting this data analysis to show up on your Excel, please come to office hours. Once you do have it, you can press it, select histogram as your analysis tool. In the input range, oh, I've forgotten something. I have indeed forgotten something. I'm getting ahead of myself. So once you have the data analysis available, you need to decide on what your bins should be. Remember, we select a bin width for histograms. So in this case, I'm going to say I want my bins, the first bin to be between 1 and 2, the next bin to be between 2 and 3, between 3 and 4, et cetera, up to 7. So I'm going to take these bins and I want to make a histogram on these data. So once I hit data analysis, histogram, you put your input range as the values of the data. So just like that. You put your bin range as the bin cutoffs that you decide upon at the beginning, which I've done here. Then you should select chart output. And when you're ready, press OK. And what this will do is it'll make a new sheet. So you see at the bottom, I've opened a new sheet. In this sheet, it'll bin your data. So at 1, we have 1. At 2, we have 0. 3, we have 3, et cetera, et cetera. And then it gives you a more tab at the very end. So anything above 7 in this case would be put into this more category. And bada bing, it made us our histogram. So looking at our data, we might say that this is right skewed, but actually that would be probably a reasonable thing to say. I would also say it's a pretty small data set, and to get really at the shape, we want to probably get more observations and then look at them a bit more. So I think that is all I wanted to do. We've done box plots and we've done histograms, and I've done an example of a bunch of the metrics we talked about in our last lecture. So thank you, everyone.